Geometry notes 7.3, indirect measurement with similar triangles. All right, go ahead and start on the warm-up problems. First thing you need to do is get the equation set equal to 0 so that you can factor it. So for the first one, we're going to add 24 to both sides. Now it feels like you can add the 24 and the 11x, but because they're not like terms, we cannot combine them. So it's going to be x squared plus 11x plus 24 equals 0. From there, we can factor it out to figure out what x could possibly be. So x squared, we can break up x and x. Think of numbers that multiply to be 24 that add or subtract to be 11. So we have 1 and 24, 2 and 12, 3 and 8, 4 and 6. So we're looking at that lesson thinking, do any of these add to be 11? They all multiply to be 24. Which ones add to be 11? All right, and it was 8 and 3. So we're going to go x plus 3 plus 8 so that they add to be 11. Next, we set each factor equal to 0. So then we're going to subtract the 3 on the first one. X equals -3. And then subtract the 8 on the second one. X equals -8. All right, the second one, just to get you started, we need to move both the 3x and the 24. I always move them and try to keep that x squared positive. So we're going to subtract the 3x while also adding that 24. So these cancel so that it's going to equal 0. So we're left with x squared plus 17 minus 3x would be 14x. And then the 24, since there was no constant over there, it just still is plus 24. All right, so now we're thinking of what numbers multiply to be 24 this time that add to be 14. So we'll see if you can finish up 2 and 3. Go ahead and pause the video and try to get the answers for number 2 and 3. All right, so number 2, if we set those factors both equal to 0, we get x equals -12 and x equals -2. On example 3, first step, subtract that 24. Multiply to be 24, add to be 2. So it's going to be +6 and -4. So we set both those equal to 0. X equals -6, x equals +4. We'll keep incorporating factoring quite often here. All right, so what we're going to do here is indirect measurement. So first of all, let's try these first two problems. If the lines are parallel, would the triangles be similar? Let's think about this. So if TS is parallel to CB, what that means is that you're going to have some angles that are the same because of corresponding angles. I think you had one like this on your assignment last week. So that angle is the same, and then that angle is the same. Okay, so yes, the triangles are similar by angle-angle similarity. So then what we can do is think of that small triangle whose sides are 3 and 6, and then we have that big triangle whose sides are 3 plus x. That's going to be what we're going to call x. And then the other side is 18 plus 6, which would be 24. So then from there, we can take the small side on the first shape, 3, over the corresponding side on that next triangle, 3 plus x. And then go back to that first triangle, 6, over back to that first triangle, 24. So you could simplify the fractions first or just start cross multiplying. 3 times 24 equals 6 times x plus 3. 3 plus x. Doesn't matter. 3 plus x or x plus 3. All right, so 3 times 24, 72 equals, and then over here, we need to distribute that 6 through. 18 plus 6x. We can subtract that 18. So 12 minus 8 would be 4. 6 minus 1 would be 5. So 54 equals 6x. And then one last step, we can just divide both sides by 6. X equals 9. Okay. All right, for that next one, this one has in a trapezoid, we know these lines are parallel again, the top and the bottom. So the angles that are equal in a trapezoid, you've got alternate interior angles. Remember, you can make that Z. So this angle and this angle are the same. And also we can make it coming the other way too. So then these two angles are the same. Okay, they're not necessarily all four equal though, unless it's an isosceles trapezoid. All right, so let's mark that again here. So I know this angle, CDE, is equal to this angle, EAB, alternate interior angles. And then also we have DCE, this angle over here, by alternate interior angles, equal to EBA. So if you can see by angle similarity, we can see what two triangles are similar. Now this is a little bit tricky because you kind of have to rotate or turn that top triangle. So I'm just going to redraw that top triangle so that it kind of aligns more with the bottom triangle. So if I turn it, E, C, D. So here is my angle that had the 2 marks on it. And then that D was the angle that just had the 1 mark. So then the sides are going to be DE was 4, and then CE was 3. And then that last side, CD, was Y. So now I'm comparing that triangle with this one down here, and now they're like oriented the same way. So it's kind of easier for me to tell like what sides should go with what. All right. So I want to find X and Y. So the ratio that we know on both of them is 10 and 4. So I can put 10 over 4. My stylus isn't working the best. I apologize. And then come back to the top triangle equals X over 3. And we can calculate that and figure out what X is. Similarly, we can come back to that 10 over 4 and then go ahead and see how we would set up the Y. Should we do 14 over Y or Y over 14? Which one comes first? So since I went 10 over 4, we got to come back to the top, 14 over Y. All right, so for both instances, then we can cross multiply and divide. I think you're going to get some decimals here. So if we cross multiply, 10 times 3, that'll give us 30 equal to 4x. And then we can divide by 4. To get 7.5. For this one down here, we can cross multiply. 10y equals 14 times 4, which is 56, and divide by 10 to get y to be 5.6. All right, let's go to the next page. All right, let's go ahead and skip 3 and 4 and jump down to the lesson problem. So for this lesson, we're trying to find indirect measurement. So something that we want to know the height of, but we can't actually calculate it. So for this example, it's showing you shine a flashlight at a mirror and the light is reflected up the wall to illuminate a bug. Why are these two triangles similar? All right, so because of the right angle there, that's one of your angles. And then the other angle that's going to be the same is this angle that they come at and the angle that they come back off. Okay, so that angle is going to be congruent as well. So these would be similar by that angle similarity. And then we can figure out what the height of the bug is. So we could go 2 over 4 equals 3 over h. Okay, and we could cross multiply. 2h equals 12, h equals 6. All right, let's go to the next one. This one says you have a person that's 5.5 feet tall casting a shadow that's 4 feet long, and a tree casts a shadow that's 12 feet long. Draw a picture. So here we go. We've got a person, they're 5.5 feet tall, and their shadow is 4 feet long. Then, at the same time, you have a tree that we don't know the height of, and we can't calculate it because it's so tall, but its shadow is 12 feet long. So what we can do is call the height of that tree x, and because of the person and the tree are standing straight up, and the angle that the sun is coming at, these are going to be similar triangles by angle similarity. So what we can do is we can say 5.5 over x equals 4 over 12, and cross multiply and solve. So if we do that, 12 times 5.5 would be 66 equals 4x. Then I can divide by 4 to get the height of the tree to be 16.5 feet. All right, the last one we're going to look at, example 2, we're just going to look at the first case, not the other strategy. It says, suppose a military engineer needs to know the distance across a river. Using a point on the opposite side of the river as a reference point, the engineer sets up right triangles along the bank of the river. Use the diagram to find the distance across the river. So you already have the right triangles, and then we have vertical angles. So then these triangles would be similar by angle similarity. So what we want to set up is that proportion. So we can say like x, what would x go in the other triangle? X is going to go with 40. So we can say x over 40 equals, come back to that first triangle, 72 over 30. So then we can cross multiply. 30x equals whatever 72 times 40 is. So we get 30x equals 2,880. We can divide by 30 to figure out what x is. And we get x is 96. Okay? So it'd be 96 feet for that third side across the water. All right, so if we look at the assignment here, it's going to start on page 17. So it's page 17 and 18. Now, many of the pictures are already set up, but if you need to draw the problem, do that. Also, the answer bank is on the bottom of page 18. All right, so try to get 7.3 done for tomorrow.